Hello, welcome to My Future Me, where we explore what it takes for you to become your future you. I'm Tiger Posey with Communities in Schools. The mission of Communities in Schools is to surround students with a community of support, empowering them to stay in school and achieve in life. And today that's what we're going to do. We're going to use our community to show this guy, Bryson, what it takes to become his future him, I guess, his future him. All right, so Bryson, what is your future him?
Being an engineer.
Being an engineer. What kind of engineer? The kind that rides in the front of a train?
No, sir.
No? All right, what kind of engineer do you want to be?
Where you make stuff and build different things.
Make stuff and build different things with your hands?
Yes, sir.
Yes, sir. All right, so we're going to build things with our hands. Do we use computers and stuff as an engineer, you think?
Yes, sir.
Awesome, so we got to learn about computers. So what we're going to do today is we're going to take Bryson around to some different places and we're going to see what it's going to take for him to become an engineer. We're going to use our resources here at Wilkes Communications and River Street Productions, and we're going to meet some engineers and they're going to show us what they do. And then we're going to go up to the community college and we're going to see what it takes to become all kinds of different engineers. We may see some robots. We may see some circuits. We may see a 3D printer. Who knows what we're going to see, but we're going to learn what it takes for Bryson to become an engineer later in life. All right? So Bryson, tell me a little bit about yourself. You wrote me a letter not too long ago, kind of explaining that you wanted to be an engineer. And there were a few things in that letter that I found absolutely amazing, all right? And he went through what he thought a day of an engineer would be. Now, do you want to go through that day with me? Let's go through a timeline of what an engineer's day is. What do you do first thing when you walk into the office? Or if it is an office, it might be a big warehouse somewhere with tons of robots zooming around. Who knows? But when you walk into work every day, what do you start off with?
Get ready to do my work and design different things.
You design different things? So what kind of things do you want to design in your future?
Like different tools, maybe?
Different tools? All right, so we would design tools. So you go to work, you go to your desk or wherever you are, and you start designing these tools. Now, these tools may be to fix other things. They may be to repair something on a space shuttle. Who knows what tools you're building, because we're not in the future yet, right? So after we get to work for a little while, we're working. What do we do then?
Get coffee and maybe
we need coffee. He's been working for a few hours. He's been up for a while. He needs coffee. Right? So we take our coffee break, we're hanging out, we're chilling, we're talking about last night's game, or probably not, maybe not. We might be talking about the video game that we played last night, right? Who knows what you're going to be doing in the future. So we talk about what we've been doing, what we did last night with our other engineer buddies, and then we do what? We go back to work. How long is our coffee break? As long as we want. You're an engineer. You can engineer time, right? You can figure it out. You probably got a flexible schedule as an engineer, maybe. All right, so we go back to work. What do we do when we get back to work?
Design more things and maybe even make them.
And even make them. How do you think we would make them? How are you going to make a tool?
A 3D printer.
Oh, that's the tool we need to make tools?
Yes,
Awesome.
sir.
Well, maybe we'll see a 3D printer today if those engineers have one. All right, so after we design a few more things, what do we do then?
Lunch.
Lunch, got to have lunch, got to keep this guy fed, we got to keep our energy levels up, we got to keep going for the afternoon. All right, in the afternoon, what do we do?
If you're not finished with your stuff, stay, and if you are, go home.
Go home. So we got to have focus. If we want to get out early, you got to stay focused and get your work done as an engineer. So we're going to figure that out today. We're going to see some guys, see if they're taking a half day today once they get their work done. All right? So let's go check in with some of our community friends. We're going to meet some engineers here at Wilkes Communications, and then we'll go up to the community college and we'll see what it takes to become an engineer. So let's go check in on those guys. You ready?
Yes, sir.
All right, let's rock and roll. All right. We're back here with Bryson. We're about to explore what it takes to become an engineer. We're going to start here with one of my buddies, Adam Hayworth, who's a CAD operator at Wilkes Communications. And Bryce and I were just checking out the area map here of Wilkes County, and we're gonna ask Adam some questions about what he does here. So come on in, Bryson. We're gonna meet Adam. All right, Adam. How you doing?
Doing good. How y'all?
I'm doing very well.
Good.
This is my friend Bryson.
Bryson, nice to meet you, buddy.
Yeah. So Bryson wants to be an engineer.
Okay.
When he grows up, and
All
we're gonna let him ask you a few questions on what it takes
All
to
right.
become an engineer and what you do day in and day
All
out.
righty.
So Bryson, what are some things you wanted to ask Adam?
Where did you go to school at?
Well, when I graduated from West Wilkes High School, I went to Wilkes Community College and went into the engineering program over at Wilkes Community College. And actually, I went to go to be a CNC machinist. But I did take some AutoCAD classes over there and continued on with the AutoCAD diploma, and of course with the machining goes right along with it. And then one day I had a guy ask me to do an internship here, and of course I knew some of the AutoCAD and kind of went on from there, and next thing you know, ended up here doing AutoCAD and joining engineering, and had a 2-year degree in engineering and machining. But also that machining degree also works just as it does in here as engineering. This is a graphical representation of our fiber optic cable right here. And also with this, we have attributed pedestals that you may see out in the field. Have you ever seen a pedestal? There's a little green box you'll see over in the ground, and it'll have an attribute on it on here, but actually in the field it's just a green box. But it'll have fiber optic cable running in through it. That way we can provide service to your house. So that way you can have your internet and your phone and your TV. So that way if you want to play video games on the internet, we can have that hooked up for you. Or watch TV, whatever you want to do. You like SpongeBob? You're a SpongeBob fan? You're not a SpongeBob fan? What about Tom and Jerry?
Looney
Tom
Tunes?
Tom and Jerry?
Yeah.
You like Tom and Jerry? Well, you can watch Tom and Jerry through our fiber optic cable. As we see here, I have put some attributes on here that have stated what is going to be at this pedestal. Now we have different pedestals for different operations, and we'll continue on through here that each cable and each pedestal are very different depending on the situation that comes up. So as we see here, as I have a BFO 144R, which is a 144 cable, which has 144 ribbons of cable in it. So as that's traveling along, that's going to have 144 ribbons of cable.
So you got little ones and the big one?
Mm-hmm.
All right.
Yep.
144 little ones and the big one.
Yep.
Out there's a map, and it shows like y'all's areas,
Mhm.
and there were these two different types of greens. There was a solid green and there was a striped green. What does that mean?
The map out here.
Yeah, it's the map out here.
Let me go see. This map here is pretty much an overall layout of what we serve as River Street Networks and Wilkes Communications. This is our overall map. So as you see here, as in Wilkes, we serve everything that is in this green area. Everything that's out in the rural communities, we serve it. Now over here in Stokes, we're building out some of that in Stokes, building a backbone to it. So we're serving all these customers that are in green. We can serve them as of right here. Also over here in Tri-County, we have some of our serving area over here, as in over here. And then of course, as we haven't said before, but those green little lines are those ones that could be a possibility for us that we can possibly get out to these customers over here that we could in the future go out to.
So that could be your future you, Adam.
That could be the future.
That could be future Wilkes Communications.
Yes.
All right.
And also we have down here in Ellaby, we're serving it, and we also have as our Fairbluff, and of course as I'm working on is Barnesville, and we also have our Saluda, which is down here in Polk and Henderson County. So we serve Barnesville, Saluda, Ellerby, Service, and Tri-County, Stokes, and Wilkes. And also we have this little area up here in Virginia that we are serving. I haven't worked on any of it, but we are planning to expand up there that we have contracted with to go up there. I don't know when the time may be, but we will go up there in the future.
Oh, that's cool.
And of course down in here, this is another possibility down here, what we could get to.
So when you said what you could get to, you would use, like, these would be your bullseyes like we were talking about in your office.
Yep.
And you would use these two places to kind of bring in.
So when you do that, you could get some of South Carolina in.
Yep, it's a possibility. Whatever.
So they'd be in 3 states, huh?
Yep, whatever we get told to build out, whatever we have the money to get funded to do that with, then we will possibly go into these other counties and to help them get fiber optic service, so that way they can have the internet to provide whatever their needs may be, or even TV.
That's great.
So you barely service anyone in Alexander County?
Yeah, we don't serve anybody in Alexander County. We haven't gone down into that yet. All of our control is over in these rural communities. I don't know of anything that we'll do in Alexander County. I don't know. It's a possibility that we will. To my knowledge, I'm not very sure. But as I know of, that we're just going to be serving all these other counties right here, as you see here on this map.
This guy will hopefully, his future him will be an engineer doing something with STEM. He really likes the STEM curriculum.
It's
So
a good program to get into.
Yeah.
Science, technology, engineering, and mathematics.
That's right.
Yeah.
That's awesome.
Yeah. Well, thank you for your time.
Absolutely.
I really
Thank
appreciate
you.
it.
Appreciate
Thanks.
y'all coming by. Y'all come back again. All right.
All right, let's head on out. We're here with Keith. He is the lead instructor for robotics and mechatronics at Wilkes Community College.
See where this says joint.
We found a
right here?
robot.
We're going to put that in a different mode.
Bryson's pretty tied up with this robot here. He's actually learning how to make a computer
Put your hand in there,
program
get
to
ready.
make this robot pick something up. So I'm going to ask Keith kind of what robot we're dealing with, and he and Bryson are working with this. Hopefully they'll have some time to answer one of my questions while he's answering all of Bryson's. So Keith, can you tell me what kind of robot we've got here?
This is a FANUC robot. It's part of the FANUC lines, one of the small robots. It's a pick and place robot. It's used in the industry to pick parts up, move it to another location, maybe where a repetitive process is needed over and over, or where it's dangerous to humans.
Right.
Applications such as welding or water jet cutting or common or palletizing. And what he's doing here is he's going to just take and pick up a product and move it. That's good. And then we're just going to drop it.
Okay.
And he's doing really, really well because he's already learned how to program this robot. In fact, I'm considering signing him up for classes in the fall.
That's great.
Okay.
We were talking
That's
with
good. Oh, right
Bryson
there.
earlier,
Right there.
and I mean,
Just wait.
he's got it down. He was.
Oh, yeah.
He's very interested in STEM curriculum. So.
Absolutely.
Thank you for taking your time to show him how to operate this thing, and I'll let you guys do what you're going to do. I'll step out of the way.
Okay. We're going to open the gripper first of all. We've got to reset our program a little bit.
Sure.
All right, so let's get the gripper open, okay?
But it'll drop in it.
Yeah, it's going to drop. You're exactly right. So press the 6, call the program. All right, then we'll recall. You remember how to go down the screen?
Yeah.
Okay. And go down one more. All right, right there, run the gripper off, so enter. And enter again. All right, now go arrow up one key, one line. There you go. Now we're going to do shift reset like we're going to run the program again. Perfect. Now hold your finger on the shift key. Keep it held down. Press forward at the same time. Perfect. All right. Whoa, right there. Stop. Release your keys. Perfect. So now we're going to see if we can pick it up, or at least grab hold of it, okay? So we're going to delete this line here. There's a lot of stuff has to take place when you write a program, right? See that says insert or delete? Go ahead and
So
delete
what
that
Keith
line.
and Bryson have been
Delete
doing
the line, yes. We're going
is
to confirm
they've been
this key here.
going through with
F4.
this super
Okay, now let's go
great game
back to the
controller
top
here.
and run the whole program over
Very
again.
expensive game controller. It's really not a game controller,
Shift,
but
reset,
they're going through. He's shown them
and shift and forward.
how to control on the back. There are a couple
Hold
of
it still.
buttons that that
enter,
you have
yes.
to have depressed in order for him to be able to move the machine, which
Gotta
is really
shift
cool.
down,
So they
hold
showed
down.
him the safety features
Let me,
of
get
this thing,
started
and they've
again.
gone
Let's put this
through,
back in different
and he's
mode.
actually maneuvered this
There you go.
robot
Try it again.
to get it to
Watch.
mark spaces,
Perfect. Now there we're going to come straight up.
and he's able to
Take
pick
your
this
finger off here just for a
thing up,
second.
and he's only been here for like 10 minutes.
So now we're going to go straight up with
So
it. Wait a minute.
Bryson's
We're gonna
got
make
a
sure
pretty
we're
good
jog
hold of
frame.
this thing.
All right, so now we're going to shift.
And Keith
Z
is an
plus.
amazing instructor, I would assume, as well.
Okay, perfect. Now we're going to go down. We're going to delete this line. Program is not hard, but it sure is tedious, isn't it?
Yeah.
And we're going to go down here to delete. And press that. Very good. So that's just, we want to delete that line. We're going to say yes, right here. F4. All right, so now we want to grip the robot. We want to grip it. Ready to do that again? The dead man switch. Got to reset. There you go. And
Now, Keith, you mentioned that it was tedious work programming the robot. Is that for?
oops.
There he goes.
Yeah, it's very tedious now that we've moved it. We'll have to rewrite our program.
But is that for safety? Is that safety reasons?
That's
we
because
want
it moves in increments of less than 1 millimeter.
Right.
Because it's very, very accurate. What we're doing is very, very low tolerance. We're not using high tolerance methods.
Right.
What we're doing
marker
here,
lid.
yes, a marker lid. But in the industry, everything has to be very, very precise.
Right.
If you're welding a weld on a car, it has to be exactly in the same place every time. So things like the mounting frame has to be very, very sturdy
Right.
and heavy, and the robot has to be very heavy so that just the movement of it doesn't cause it to get out of alignment.
Right.
This robot also has a camera on it, so it can see where it's at in 3D space. So
Very
it
nice.
can actually sort parts that are laying at random. It can pick them up.
You can pick it,
if
you
you
can
drop
choose
them.
out which one that
Yeah.
if you've programmed it in here to pick out something of that size and shape, it knows exactly where to go.
For example, you could have bearings coming down a line, and the camera can see where that bearing is located, inspect that bearing. If it's the wrong bearing or the tolerance is incorrect, a robot can come over and pick it up off the line, put it in a reject pile, or it can take those bearings and stack them one on top of another,
Right.
or put them in a box and in a crate.
So the tediousness is really to keep everybody safe and everything functioning the
Yes.
way it needs to function.
Yes.
Gotcha.
And in just a few minutes' time, he's wrote a program that you can see right here
Right?
that creates all of these points, and he already knows how to do the
And then
safety.
could we get over here and like drop it and that be some of our?
Yes, you can. You can. You could do all of that. If we had plenty of time, we could do all of those things.
Right. So he's gotten it to where it will actually. Can you run that program just to see what it'll do? Or?
We'll run it without the
Without
device
the-
in it. So
yeah.
yeah, you go ahead and try to run it on your own. You try it now.
Oh,
Okay, you're good. And forward.
So he's programmed in this movement for this
it's still
robot.
off the grippers,
Yep, you did all of that
Very nice.
but then it closed back up
it
because
did.
we don't.
because we told it to close. See where it says call the gripper on program? He's actually run a program and a sub-program.
Right.
So he's actually done 2 programs here
That's
today.
great. So what do you think, Bryson?
It's awesome.
It's awesome. That's
pretty
good.
fun, isn't it?
Yeah, that's good. So
We
could-
can actually take and put a pencil in its hand or an ink pen and have it write out your name on a piece of paper even.
really,
We could do that.
that's pretty neat.
I
So
wanna
you
do
can
that.
you
Not
can
much application for that though.
but you could, given the time and the effort, you can make this robot really do whatever you want it to do.
Yes,
And
yes.
so Bryson could potentially, his future self could be writing programs to make robots do whatever we need them to do.
Yes, we have people in Wilkes County that are programming robots.
Really?
Yes.
That is amazing. That is amazing. Well, something you're interested in? I mean, that's pretty neat. In about
I
10
want
or
one.
You want one? What do you think? What can we pick one of these things up for these days? What can you get a robot for these days?
Probably get one of these for about $35,000.
35,000. Hey, we'll work towards that, right? Awesome. Well, Keith, thank you for showing him how to program this robot. I think we've got a few more things that we're doing here at Wilkes Community College. It's really, really cool to see that here locally we can do these things. You have a robot that could stretch his lumbar out, get him all stretched out. Could we
Probably
fix
if
your
we got our
robot?
finger caught in it, it would
Yeah,
stretch out really well, wouldn't it?
stick your finger in there and let it yank. Oh, you could do the pull my finger joke with the robot.
I guess
Do
we
they have a
probably
sense of
could.
humor? Yeah. All right, well, let's go. Let's move on, see what else Wilkes Community College has for us, and see what else we could do.
Thank you. Nice
Yeah.
having you here today.
Thank you. Appreciate it, Keith. Thank you very much.
Thank you.
Thank you.
And once we get that done, we'll start putting in maybe some of the LEDs and the resistors and things of that nature.
Bryson, I'll leave you for 1 minute and you make your way down the hall and run into Robert here, our lead instructor, and he's got you working.
Got him
already.
working, yes sir. We got him working.
Robert, thank you so much.
Oh, you're
I guess
welcome.
you're learning how to build a circuit and all that, so I'm just going to step out of the way. And I met somebody pretty cool over here that we'll introduce in a few minutes to you, Bryson, but I'm going to let you and Robert go on. Looks like y'all know what you're doing. I'm going to step back out of the way. I'm glad
Got
you
it right.
found your way down here.
Got it right, don't we? Thank you, Tiger. Looking good, man, looking good. You don't want to get too much solder. That's perfect, man. I thought you said you never soldered before.
I never have.
Ah, you're lying to me. I see.
I get stuff real quick.
Catching on good, man. Perfect. There you go. Move around a little bit. Yes, sir. Touch the soldering iron. Touch your solder. See how cool that is? How easy that is? Put just a little more solder. You don't want to be able to see the hole right there. You see that little hole still sticking up through there? There you go. That's perfect. Now, if you run into that problem, watch this. You can just kind of take your soldering iron, touch it, and then move it away. You see what I just did right there? Just kind of touch it and move it away. Because you have enough solder on there. There you go. See how perfect that is, man. You're telling me a fib, man. You've soldered before. You're doing this too good not to have done it before. Did you enjoy the robot down there?
Yes, I did.
If we have time later, we'll let Willard demonstrate his robot to you that he built. And they just touch the soldering iron. They're taking perfect, man. You only got 2 more to go on that one. One on that side, one on that side. Perfect. Now, we're done with that one, okay? So now you just take your soldering iron, do that because you don't want to touch it and burn yourself. I've been teaching here at the college for 36 years now, so I'm an old timer here. But when I first started teaching here, we did not have a soldering class in the curriculum. We did some soldering, but we didn't have a soldering class, which we do now. But I had a student who graduated, and she went to work at an alarm installing place in Hickory, and about 6 months later she got fired. And she was a great student, great person, and I said, why did you get fired? She said, because I couldn't solder. So I swore that from that point forward, every student that graduated from my program would be able to solder. So we have a whole semester of soldering that they do.
So
And
it's an important skill
Absolutely.
that they have to have.
it is a critical skill to have.
I can't tell
Yes,
what
you
you're doing. I can't tell what he's doing, but he looks like he knows what's going on.
So take a second right here, Bryson. This is called a breadboard, and before you solder that circuit, you might say, well, I want to make sure that circuit would work. So you build it on a breadboard where you don't have to solder components. You just take that, and you see how you just stick that on there? You can build a circuit on this breadboard. Willard asked me yesterday, he said, why do they call these breadboards? Well, I'm an old enough man to know that when I was growing up, you actually took a piece of butcher block and drove little finishing nails onto it, and you actually just connected you just wrapped wires around the nails to make electrical connections.
Right.
So that's why they were called breadboards, because some people took, just a piece of board like you might need.
Slice
bread
it
on.
like you
Right.
slice bread
Right.
on. What with the skills he's learning now, what kind of careers would this lead to? What are some of the things that Bryson would be able to look forward to in the future, knowing these things?
Well, we're entering into an era of miniaturization and surface mount soldering and components and so forth. The world has still not transitioned into that, morphed into that complete finished phase.
Right.
So there's still tremendous need for people who can do what's called through-hole soldering, which is what this is, rather than surface mount soldering.
Right.
Because if you run a manufacturing firm and you've got $10 million worth of machinery that has printed circuit boards in it like this, you're not likely to spend $20 million to replace it with new machinery. So there's still plenty of manufacturing facilities that have the need for these skills. So it's not just a replace and throw away the old product world. It is technically, but we still have to have those skills.
Right.
So those skills are, the soldering skills are critical, but also all these components that Bryson's using are critical to his success. Understanding what each component does, understand what its purpose is. You know, anytime an engineer designs and builds a circuit, there should never be an unnecessary component on that circuit board. Never.
Wasted space.
Right.
No
It's
wasted space.
and money. If that thing only costs a dime, you think, well, it's only a dime. What if you're going to make 10 million boards?
Right.
Now you've got $100,000 or $1 million worth of
Right. Product
stuff
that you don't need.
that was wasted.
Right.
So you know, it looks like he's doing a pretty fair job here too.
Could you explain maybe a few careers? Oh, well, it looks like he's finished. Could you explain a few careers that you know,
Yes.
this program would lead him towards?
We have graduates who go into various fields of technology and technician work. You know, here in Wilkes County, you know, we've placed them at Wilkes Communications. We've placed them at Lowe's, Carolina West Wireless. Yeah, that's yours to take home with you. That and this one, so you can practice soldering at home. We're going to give you one of these little blue things to take home too, so you'll be rocking and
I get a bunch of stuff from this card.
rolling. So
Let's hear about the careers.
as an engineering technologist, you know, it's just wide open. We have students who go to work at the hospital, servicing some
all
of their
the
equipment
like
there.
so like in surgery rooms and those.
Yeah,
kinds of
they would
things?
service, for instance, the dialysis machines.
Okay.
You know, they have to be bonded and certified to work
Right.
on a dialysis machine. So they get trained in specific things that they need to do, and then they work for a company that services all that equipment
Okay.
and does for them. So all these things that are going on in an operating room or an emergency room are things that are necessary. Hooked right together, didn't it? Almost like that. A little bit more solder in there. There you go. All right, now let's get your black wire going, and then we'll turn off the noise maker. That's perfect. Okay, we ready to try this out? Ready to get a 9-volt battery and try it out? and see
All
what-
right. So if all goes well, what's the outcome of this circuit that he just put
Okay,
together?
it's gonna. These
So,
LEDs should
Do
kind of.
do I get some of these to take?
We'll get you a 9-volt battery, man.
You'll get a little bit of everything, Bryson. Now I want to show you something. See how those little legs are kind of spread apart there? We don't need that. So we have a thing called a
Those are the
chip
circuit
lead
pieces.
former. You have one here that's close by. One of those chip lead formers. Here. Here. What this does, Bryson, is you just drop the chip down on this. Just drop it right down on it, and just kind of go. And now it'll just drop straight down. You remember the mouse hole thing?
Yeah.
Okay, you see where the mouse hole is on this one? Mouse hole is this way. So you want that little mouse hole to point toward me, right? Turn it around the other way. Turn
The
around
mouse
toward me.
hole?
Yeah, the mouse hole right
Oh.
there. You see it right there.
Look at that.
Cool
They're
is that?
lighting up different. Oh, it's like Christmas.
It's kind of random stuff. It's just doing for you. How about that?
Give it up top.
Give me.
What about yeah?
All right.
Nice job. Nice
Good job, man.
So, since we've got that done, you want to meet somebody who's putting this into action, who's actually working on this and is building a robot, and then Willard that's taking Wilkes Community College to the national competition.
Sure.
We'll
You want to
go
meet that guy?
Yeah.
Yeah, and let's get with it.
Need a kid,
Here we are with my future me. We've got Bryson here who's learned all kinds of crazy stuff. And we got Willard who was once a young Bryson, I'm sure, and was totally interested in engineering and electronics and those kinds of things, right? All right, so Willard is who we were talking about earlier that is representing Wilkes Community College, the state of North Carolina, in the national competition in Kentucky. So what he's got here is, well, let's let him explain. And Bryson, I'm sure you've got some questions about this. But yeah, Willard, if you will you explain what you got here?
Yeah, like he said, I was one of the ones that I'd get a new toy for Christmas, and by the end of January, I've taken it apart, trying to see how it works.
Do you take
And
your
so
toys
that's-
apart? Yeah. Okay. Good.
That's been
Good
a
start.
theme for me. And so, what this is for a competition that community colleges and universities do. It's called Skills USA. And so it lets college students like me compete at a state and a national level I think they've got over 100 different competitions. And so the one I'm in is called Robotics Urban Search and Rescue.
Okay.
And what we do in that is you have to build a robot to various specifications, and that robot goes and runs a course. And they put you in, it's like a simulated neighborhood, so it's about the size of a normal room. And there's a bunch of tiny buildings and mailboxes and all this stuff. And you have to take your robot in there, and you have to find 2 red blocks, and they're supposed to be like bombs. And so you have to go in and get the 2 red blocks out with your robot, and you have to take them away from the neighborhood and make it safe again. And so they time you on that. You get about 6 minutes. And then, as well as that course, we do up an engineering notebook with schematic diagrams.
So the process of you being able to build this is
Yep.
kind of a timeline of what you've done to prove your work, right? To show
Yeah.
kind of what you've done. All right. Well, Bryson, you want to step in here and let him. Let's see. You got any questions as to what we're looking at here?
What are the switches for? Like, what do they do?
Okay, so the main 2 controls here on our controller, we have the arm control to bring the arm in and out, and then we have one for the grabber. And then for the robot, we have forward, backward,
turn
and
left.
right and left. And so that, there's 1, 2, 3, 4. So if we look down here on the robot, this is our receiver that picks up the signals from our remote. And you'll see there's little labels, channel 1, 2, 3, 4, and then there's channel 5 and 6, and those aren't hooked up right now.
What are channel 5 and 6 going to be?
Channel 5 and 6, we don't have it set up right now because we're still getting ready for the national competition. It's coming up here in a few weeks. So those 2 controls, we've got another board that we're going to mount onto this, and we're going to put our camera on a mount with 2 more servos like this, so our camera can look up and down and then left and right, so we can move
So
the
where
camera
would you
around.
see from the camera?
From the camera,
Like, how would you see it?
we have a receiver, and it hooks up to a TV. And so at the competition, we're sitting at a table with a TV, and we can look and see what the camera sees while the robot's on the course.
So your search and rescue. So this would be places that it would be dangerous for humans to go.
Yep.
Those kinds of
Yeah.
things. So we were just in there, and Bryson learned. He put together a circuit. Is this how many circuit boards have you put together for this thing?
We've put together the one for the camera, and we'll see if we can get that in a minute.
Right.
And
That one.
we've got this and this one, and these are for our 3 big motors here. These
Okay.
2 controllers are, and so they plug into our receiver here, and they take the tiny signal coming out of that receiver, and they turn it into a big signal, a 12-volt signal coming off of our battery to power these big motors.
And so these motors, they've got little creases in them, so it grabs onto the chain, which makes the wheels move.
Yeah. Yeah, so on the chain, we have our main motor here, and as that spins, let's see if I can show you. As that spins, let's see if I can show you that. So the chain is driven by the one motor, and then it goes down to all the different wheels to turn them at the same time.
And then so these wheels they're more of these, so it keeps them going.
Yeah. Yeah. And the way that works, you see, as this is turning, that's turning counterclockwise, but this is turning clockwise. So we have to have this to change that rotation so that all of our wheels
go the same
go the same direction.
Oh.
So it's just like it would work if you had gears, but we use the chain instead.
That's
And
pretty
then
neat.
So these switches up here, what do they do?
These are, for what I showed you there, those two plugs that we haven't used, so they don't do anything right now.
So, can you make this thing dance?
Yeah.
Let's see it.
Why don't you give it a try? You've seen how it works.
Now, you do realize you're leaving a robot that you're taking to a national competition in the hands of 10, almost 11-year-old hands. So, good luck.
We built it tough. That's our job.
Built Wilkes tough, huh?
Yeah.
That's right. Whoa. Okay, so I see. Whoa. Oh, see, now you're making me nervous, Bryson. Okay, so I see that, and I really like the the show. Oh my gosh, the show BattleBots, those kinds of things. Is that kind of what you've done here? Oh, see.
Oh God.
Is that what you've done here? Would somebody be able to come here and build a BattleBot? They would have the knowledge. They would be able to
Yeah.
learn what it takes to
Yeah,
make
there's-
one of those things.
There's another level of Skills USA, and they do
Come on,
high
man.
school, and even middle school level robots. And one of their competitions at the high school level is actually like BattleBots.
Oh, really?
So they build robots and they put two of them out on the field and they compete.
So we've got kids in middle school, because you're going into what, 6th grade?
Yeah.
So in 6th grade, he could learn how to put together one of these robots?
Yeah, you could see if they've got like some STEM classes, they might be involved. And there's another program called TSA, Technology Student Association.
Okay.
And they also do stuff at the middle school level.
Great, great.
Yeah.
Well, Bryson, today we've seen the robotic arm. We've learned how to build circuits. We've seen this cool robot, which puts everything kind of into place. What do you think about this engineering career stuff?
It's awesome.
It's awesome. What's your favorite part so far, you think? This whole, what, the robot sitting right here on the floor
there.
with me and Willard playing
In
with the
there.
robot? Oh, in there?
Soldering.
The
Yeah.
soldering and putting together the circuit?
Yeah.
So you like doing things hands-on, right? Oh, you're attacking Willard.
Grab on, grab on.
See if you can grab his finger.
Oh.
Okay, so we got a rubber band there, Willard. What's the deal with the rubber band? Oh, that's pretty cool.
So this is, for the competition, we're going to 3D print a grabber, but this one is one we got out of a kit. And so we had experimented with covering it in some,
You are a troublemaker with this robot, Bryson.
we had experimented
I think you
with
may need a
covering it
roll bar to
with
put
some
it back
rubber
up.
and also rubber bands to see
Uh-huh.
what would grip better.
Okay.
And
To
so
grab
on
your
the
red
one
boxes, right?
Yeah, and on the one we're gonna 3D print, we've actually got some rubber treads that we're gonna glue onto it.
Pretty mischievous. We got a mad scientist here, guys. All right, Bryson. Willard, thank you for sharing your robot with us. We really do appreciate it. Best of luck in the competition. Let us know how you do. We'll come and maybe do a follow-up with you. It'd be great. It'd be great. So, Bryson, flip this guy back over. Relinquish control. Stop. Stop. Relinquish control of the robot. Willard, thank you very much. We really do appreciate it. Bryson, say goodbye.
Bye.
Bryson, do you feel like you have a good idea of what it's going to take for you to become an engineer in the future?
I have to learn how to do some of the stuff that they do.
Yeah, I think you probably have to learn to do all the stuff that they do, don't you think?
Unless I already know how to do it.
Unless you already know how to do it. High five, I'm outsmarting me. All right, so what was your favorite part about today?
The circuits, when I was making the circuits,
What made it your favorite part? What was so cool about it?
I got to make it and I had a first experience
What was your first experience?
when I was making the circuits.
So soldering, that was your first time soldering?
Yes.
That's cool. Robert did a good job teaching you, huh?
Yes.
Yeah, that was cool. And we met Willard with his robot. That was really neat. You got, you were attacking. That was an attack robot in your hands. It was supposed to be search and rescue, but you turned it into an attack robot. That's pretty cool. What else did you enjoy about today?
The arm,
The arm, the robot arm, the big yellow robot arm.
the big yellow one.
Yeah, that's cool. What did you enjoy about that?
I got to control it, and
Yeah.
it was actually pretty fun.
It was actually pretty fun. That was pretty tedious though. You had to program the thing, right?
Yes.
Yes. Well, I want to thank you very much for sharing your letter with me. I'm glad we got to come up here to Wilkes Community College and see what it takes. I'm glad we got to meet somebody at Wilkes Communications that's what they do every day, is use what they learn actually here at this school, and they use what they learn every day. So thank you. I learned a lot today, and we want to thank Wilkes Community College. We want to thank Wilkes Communications. And of course, we want to thank Bryson here for his interest in engineering. And I think he's going to go a long way and become an engineer one day. Hopefully, he'll be representing Wilkes Community College or the college of his choice in a national competition one day. So, hope you've learned what it takes to become an engineer. And if that's what your future me wants to be, go for it. You know where to go.